Yeah, I just recorded, but I didn't record the earlier one, but that's fine. So we have f equals x squared, g equals 3x minus 2. So you want to do f composite g composite f, right? So
Yeah.
what you will be doing, right? You basically have 3 layers, right? The input x, right? So you have f of g of f of x, right?
Mm-hmm.
Okay. And then you start from the inside. You start from the inside. So it's inside out, inside out. So your f, this is your f, right? F is x, f of x is x squared. So f of x will be replaced by its equal, which is x squared, right?
Mm-hmm.
So you'll be dealing with g of x squared. This is your g, right? This is your g. When the place of x is replaced by x squared, the x will be replaced by x squared. You see that how that is done? G of x is such. When the input is replaced by x squared, all the inputs at the same place are replaced by the same input. So this x is really a placeholder.
Mm-hmm. I see.
Okay, so g of x squared now, okay, g of x squared now, g of x squared is 3x squared plus 3x squared minus 2. So this is going to replace g of x squared. You see that?
Mm-hmm.
Okay. And then we will be dealing with f of 3x squared. And this is f of x. Right? This is f of x. That's f of x. When x is replaced by 3x squared minus 2, when this x is replaced by 3x squared minus 2, and this x will also be replaced by 3x minus 2. So finally, you're going to get this guy. That make sense?
I see, yeah.
Okay. If you, excuse me, if you look at the flow, excuse me, if you look at the flow, here, right? Your input, right? So this the flow for that composition, right?
Mm-hmm.
So your x will be the input for f of x. Okay. So the first rule you apply is f. It comes out as f of x squared. F of x is x squared. So the output for that is x squared. Now you're going to take this guy as input to g. G. Okay. So x squared is the input for g. That's how you get this piece. The input is g. If the input is x for g, you get 3x minus 2. If the input is x squared for g, then you're going to get 3x squared minus 2. Okay. And this one in turn will be used as the input to f. Okay. And that f is taking this guy as input. So finally you're gonna get that from inside to outside.
I see.
Yeah. So that's a composite function. So you can see from our basic functions, those 22 basic functions, you can create all kinds of functions by composition, by adding, subtracting, multiplying, dividing. Make sense?
Yeah. Can we do one more where it's a little bit different? Like we change around the letters?
Sure. So how would you like to change it?
Let's do G composite F.
Sure. G composite F. Okay. And this is our F and G. So, okay, so I'm going to put it next to us. Okay.
Okay.
So we will have G of F of X. Okay. And then you start from the inside. So you have G of F. F of X is X squared. So you replace F of X by X squared. Yeah.
Yeah.
Then you'll be working for G of X squared.
Which
so you have
then
a
you plug
G,
in
yeah. So G of X squared, that's going to give you 3X squared minus 2. So 3 times X squared minus 2. And then you compose G again. So this time you're working G of 3X squared. So that's going to give you 3 times, right? 3 times X, your X now is 3X squared. So this is the entire thing. Minus 2. You see that? G of, let me put this under so you can see better. G of X is 3X minus 2. Now X is replaced by 3X squared minus 2. So this X will also be replaced by it. Okay, minus 2. You need to view X as a placeholder. So let's make it a placeholder instead of being confused. Okay.
Okay.
So when the heart is replaced by X, that's X. When the heart is replaced, when X is replaced by heart, and that's replaced by heart.
I see.
Now the heart is replaced by 3X squared minus 2. And that's what you get. You see that? So this is the heart. This is the heart. You know what I mean?
I think I understand it. So
yeah.
Let's first say, no, that's not gonna work. Never mind. I have to write it down literally. It's okay. No, I think I understand it. I think I'm trying to understand it a little bit.
You know, this idea is completely implemented in computer programming.
I see. Okay. Yeah, that's all the questions I really have, because those are the only two I really didn't feel confident about, to be honest.
Well, you asked them a very good question, because these, once you're able to compose, in the future, you need to learn how to decompose. In calculus class, you need to be able to decompose. If you can decompose, you can use the chain rule properly. I'm thinking I'm thinking maybe I should do decomposition before I leave. I will see if I have time.
Okay.
Because
Now I,
decomposition was not very much taught in most of the textbook. But anyway, go ahead.
no, I mean the only questions I really have are about the midterm, but I can ask that about tomorrow. I can ask that tomorrow though.
What about it?
No, I was simply gonna ask like how many questions are there? How much time do we have for it? You know, simple stuff. And like I guess like another question would be like on Thursday, are you gonna like we do like a quick review on like what we have to learn a little bit, like what we have to like relearn before we take it, or we're just gonna like go to a next section for that?
I will do I will do a review for you guys tomorrow.
Then that was my questions to be honest, because everything else I'm pretty confident. I have everything here in my notes, and I'm probably gonna study again. And we have 3 tries, right?
Yes.
Okay, I'm making sure because like sometimes I think I'm correct, but and it doesn't turn out true.
That happens to everyone, including myself.
And it's due Saturday, right? No, Sunday.
Sunday night.
Okay. Yeah, that was all the questions I really have. Thank you so much for
Not a problem at all, Jacob.
yeah, and sorry for like saying so many questions in class, by the way. Sorry about that.
Oh, no problem. I like that. I know I like to have interactions with students.
Okay. Well, you're gonna see a lot of that tomorrow, to be honest. So thank
Okay,
you.
no problem. No problem. Bring all of your questions to me.
Okay. Thank you, and I'll see you in the morning.
Okay. No problem. Have a good night.
You too.
Bye-bye. Thank you.